Physics Part 427. For the broadcast of music, the information signal will contain a wide range of frequencies, possibly from about 20 Hz to 15 kHz. A typical frequency spectrum of such an amplitude modulated wave is shown in the figure. In practice, the very high frequencies in music may not be broadcast so as to reduce the bandwidth of the transmitted signals. Some quality of the production will be lost, but what normal broadcasting, this loss would be minimal. The frequency spectrum of the frequency modulated FM wavelength differs from that of an AM waveform. The FM waveform has additional side frequencies that are multiples of the information signal frequencies, resulting in greater bandwidth of the same range of the broadcast frequencies. Relative advantages of AM and FM transmissions. The AM radio transmissions on the long wave LW, medium wave MW. The AM radio transmissions on the long wave are LW and medium waves are the MW and short waves are SW. Wave bands are broadcast over very large distances so that one transmitter can serve a large area. FM transmissions have a range of only a range of about 30 kilometers, and this range is by line of sight. Consequently, many transmitters are required to broadcast over a large area. FM can be used to serve small local area, but it is simple and cheaper to broadcast using AM. The bandwidth of AM broadcast on LW and MW wave bands is 9 kHz. This means that the highest frequency that can be broadcast is 4.5 kHz. This is quite adequate for a speech. However, the lack of quality of the muscle is easily noticed. On the very high frequency VHF wave band, the bandwidth of an FM radio signal is about 200 kHz, giving maximum frequency that can be broadcasted of about 15 kHz. The FM broadcasting does therefore offer high quality. The long wave LW WW band has a range of frequencies from about 30 kHz to 300 kHz. If the bandwidth on each AM broadcast is 9 kHz, then theoretically 300 to 30 and 9 is equal to 30 transmitters could broadcast in the same area without causing interference between each other. In practice, the number would be less than this so that the space in the frequency spectrum is left between the transmitters. For FM broadcasting, 300 to 30 divided by 200 is equal to one transmitter could broadcast in LW wave band. The number of transmitters that can share the same wave band is much larger of AM than the FM. For this reason, FM is broadcast only at frequencies in excess of meter kilohertz or meter hertz. Electrical equipment that produces sparks also produces electromagnetic waves. For this reason, the ignition system of the petrol engines must be suppressed. These magnetic waves are detected as interference by the aerial in radio. The aerial in radio.